Alright, so, excuse me, took a quiz yesterday. So if you didn't take that quiz yesterday, make sure that you get that done ASAP. Today we're going to talk about infinite geometric series. Monday, we'll continue with infinite geometric series. Tuesday, formative in the MRC. Wednesday, we'll finish up infinite geometric series. We'll also try and get in some review. I don't know how much review we'll get in. Depends on how much infinite geometric series we need to talk about. On Tuesday, Thursday of next week is your test, because next week, Friday, is Battle Royale. So they haven't told us yet, even if this class is going to meet. The first class won't meet because we'll be down in the field house listening to some music. And then this class, we might be coming back from there right now. We might not. I don't know. So we don't have. So right now, I got nothing planned for next Friday. So just so you know. Okay. It is the end of the quarter next week, Friday. Just so you know. So if you, and since quarter grades affect eligibility for athletes and I don't think there's a spring play anymore, but pop concert and all that stuff, if you got something missing, you got to get that in. If you want for sure to have it be on your quarter grade, if you want to guarantee that it's on your quarter grade, Tuesday is the deadline. Okay? If you wait until Thursday to hand me a bunch of stuff, I can't guarantee you that I'll have it on there for the quarter. I can't guarantee it. Okay? So, but if it's in by Tuesday, I will guarantee that it'll be on the quarter grade. For some people, that's a couple of tests, a couple of quizzes, lots of homework. Remember, any homework that's turned in can be fixed if you did not get 100% on it. Okay? And there is no deadline for that. So if you want it to show up on your quarter grade, it's got to be in by Tuesday. Okay? If it were me, I'd go back and I'd make sure that all of my Chapter 12 homeworks are fixed before next week, Tuesday, Wednesday, Thursday, in that range, so that you have, one, you understand what you're doing for the Chapter 12 test, which is next week, Thursday, and two, you get the best grade that you possibly can get. Yeah? Lots of people are hanging on to their current grade by the skin of their chinny chins, or they're very easily in that could jump up to the next grade level range. Yeah? Yeah? So, there's not going to be a lot of notes in the first, I would say in the next 15 minutes. Jot down what you want. A lot of the stuff that we're going to talk about here on the next couple of slides is abstract type stuff. Okay? But it's thinking type stuff, but I think that you know most of the answers to the questions that I will be posing here in the next couple of slides. Okay? So, first off, looking at these two series, they're not sequences because they have addition signs in between. What can you tell me from everything that you've learned in the last 2.5 weeks? What can you tell me about those series? Can you tell me about those two series?
They're both geometric.
Why are they both geometric?
Go further. the next term of every sequence is not the same.
Is
Where for it to be arithmetic,
Yep.
it has to go by the same.
has to increase by the same or decrease by the same amount. Okay, and that is not the case. Okay, all right, but we can multiply by something to get the next term. Okay, I like it. All right, I would agree that both of those are geometric. On this left one, what is my R value? 1/3? Because the bottom is growing by, or is being multiplied by 3. Okay. What is the R value on the right? What do you got? 2, multiplying by 2 every time. Okay. If I were to graph them, if I were just to basically create a scatter plot of those series, it would look like that. Okay? Where the horizontal here, the X, if you will, is, there it is, the X down here is term number. And the Y, the vertical, is the value of the term. Yeah. Can I find the sum of the first 5 terms? Can we find the sum of the first 5 terms? How would you do it? Add them together, right? Could add them all up. Okay. Could use a formula, right? We could use our sum formula that we had from last week, and we could have where n is 5. Our first term g sub 1 would be 2 in both cases, and then our r value is our r value, and you can plug that in and get the sum. Okay. Could I find the sum of the first 6 terms? Very easily. Multiply the series number 1 by another 1/3. Multiply series number 2 by 2 again. Find the 6th term. Add that to my already existing sum. Yeah? Okay. Or, again, g sub 1 is 2, n is 6 now, and our r value is r value. Use the formula. Okay. What about, could I find the sum of the first 100 terms? Yeah. Okay. Again, using probably on that one, we probably want to use the formula. Probably don't want to have to multiply by 1/3 100 times, or 94 more times, or multiply by 2 94 more times. Okay. All right. At that 100th term, okay, so I got 100 terms in my series right now. Okay. On the left, in series number 1, what's the value of that 100th term? What would the value of the 100th term be in series number 1? Roughly.
Be really close to 0, right? It's actually 2 over 3 to the 99th power. Okay? Which is really close to 0. So when we add up all those terms, so let's say we found the sum of the first 100 terms, and it ended up being 7.6. I'm just making that up. Okay? Right? So it's 7.6. If I say now let's find the sum of the 101st term, or of the first 101 terms, what really am I adding to that 7.6 value? What? No, because that's already in it. So if that 100th term is almost 0, that 101st term is going to be what? Even closer to 0. So really, is it going to change my value at all? No. My sum's probably still going to be 7.6. Okay. What if I go out to the 1,000th term? What's the value going to be of that 1,000th term? G sub 1,000. What's the value of that term going to be? Oops. The value of that 1,000th term is going to be, if the 100th term was almost 0, and the 101st term was even closer to 0, what's the 1,000th term going to be? Even much, much closer to 0, right? Okay? All right? So really, the farther out we go, the smaller and smaller the terms get, the less impact they have on the sum. Okay? Put that one in the old memory bank. Switch over to series 2 now. Okay? Can find the sum of the first 5 terms, right? 6, 14, 30, 62. Yes? 62, okay. If I add the 6th term, what's the sum going to be? Well, what is the 6th term? 64. So 62 plus 64 is 126, right? Okay. Does that make a big difference in that sum value? Almost doubled it, right? Actually, even more than doubled it. Okay. Next term. Next term is going to be 128. So my sum now of the first 7 terms is up to 254. Next one's going to be 256. My sum's going to be 510. My next one's going to be 512 as my next term. So my sum is going to be 1022. See what's happening to my sum there in that one? Okay. As each term gets bigger, what happens to my sum? Bless you. It almost doubles every time, right? So if we go out to the 1,000th term, how big is that 1,000th term? Ginormous, right? Probably well over 1 billion. Probably even closer to 1 trillion. Okay? If I add that to my sum, if I add 1 trillion to my sum, is that going to change the value of my sum? Big time, right? Okay. So the point of all of this is that the left series converges to 0. The terms are converging down to 0, so we can find an infinite sum in a converging case. The right one diverges. Each term is getting bigger and bigger and bigger. So we can't find the sum because the sum is dramatically changing with each successive term. On the left, the terms are getting closer and closer to 0, so what we're adding doesn't really affect it at all. On the right, the terms are getting bigger and bigger and bigger, and so what we're adding makes a huge difference. Okay? So those were positive R values. What happens if our R values are negative? So on the left here, I've got an R value of negative 1/2. On the right, I get an R value of negative 2. The graphs here look like this, where they alternate from positive to negative, then back to positive, then back to negative, then back to positive, then to negative, and so on and so forth. Okay? But notice what the graphs are doing. That horizontal line through the middle of the graph, that's 0. Okay? So on a converging series, yes, they are alternating, but they are still getting closer and closer and closer to 0. On a divergent series, they are alternating, but the next term is getting farther and farther and farther away from 0. So again, here the terms flip from a negative to a positive. However, they still keep getting closer and closer to 0. So at infinity, on the left one, we can find the sum. At infinity, on the right one, we are not able to find a sum, because each term is having a big impact on that sum value. Okay. One more set of R. What happens if R is equal to 1? Or if R is equal to negative 1, then it would be 2, positive 2, negative 2, positive 2, negative 2, negative 2. So here on this one, the terms don't diverge or converge. Okay? They stay the same. So the 1,000th term in this series, what's the 1,000th term going to be? 2. Right? All the terms are 2. Okay? So if we're adding up a bunch of terms, and we add 2, that's going to change the value. Even though that number, as the farther and farther out we go, gets pretty big, it still is changing, and it's noticeably changing. Okay? So in this case, no sum exists. Because we're always adding 2. So if you take all of that into account, so if r is equal to 1, no sum exists. If r is negative and less than, so if it's in between 0 and negative 1, we get a sum. If it's less than negative 1, we don't get a sum. If r is between 0 and positive 1, we get a sum. If r is bigger than 1, we don't get a sum. If we take all of that into account, what r values then would produce a sum?
Less than 1 but greater than 0.
Okay? So could we say negative 1 is less than r is less than 1? Like that? Which is less than 1 but greater than negative 1, right? Did you say 0 the first time?
I think so.
Okay. Can it be 0? Can our r value be 0? Can it?
It's 0, then it's not changing. Right?
So the first term is going to be whatever we want it to be, right?
It wouldn't be a
9.
series if it was 0.
Because what would happen?
It would be 0.
First term would be a number. Second term would be
0.
third term. And 0's all the way out, the rest of the way out, right? So the sum would ever be whatever that first term is. Okay? So, I mean, technically, yes, we can be equal to 0, but those are the easy ones because it's just whatever your first term is. Because every term after that is 0. Okay? So that's the r values that produce sums. If it's not in that range, if r is not in that range, no sum exists. Say that again so you can write that down. This is something you for sure want to write down. Okay? If r is not between negative 1 and positive 1, and we're taking an infinite sum, no sum exists. If r is in that range of values, we can find the sum, and the sum is going to be the first term divided by 1 minus r. In a couple of minutes, we're going to do an infinite geometric sum problem. We need to find how many things in order to calculate the infinite sum. How many things we got to find? Two. We got to find two things, right? What are they? We got to find G sub 1 and we got to find R. Which one should we find first? No. Why do we want to find R first?
Then you can trace it back to find G sub 1.
Nope. Why do we want to find R first?
To make sure it's between negative 1 and 1.
We got to make sure R is between negative 1 and 1. Because if R is not in that range, we're done. We can't do it. We can't find the sum unless r is between -1 and +1. So that's the first thing you want to find. Okay? You want to find r. Now, we're talking geometric series, right? How do I find r? There's two different ways to find r. How do I find it? What you got?
It's like one number and you divide it by the previous number.
So you take any term in the sequence and divide it by the previous term in the sequence, right? The one right before it? Yep, love it. That's one way. Okay? Take any term in the sequence, divide it by the term right before it. Okay? That's one way. What's the other way? Specifically when it's in sigma notation, because you're going to see a lot of sigma notation. Or given the rule. How do I find r in the geometric rule? We got
It's the number with the exponent.
the number with the exponent. It's the term that's got the exponent attached to it. Okay? So that's the two ways to find r. And you're going to do that first. Because if r isn't in your range, you're done. No need to go on. Okay? So then the second thing you'd want to find is then you want to find g sub 1. Okay? If you have a list, it's the first one. If you have sigma notation, you take the bottom number, put it into your rule, that gives you g sub 1. Okay? So that's the first thing that we're going to find. Okay? Second thing we're going to find. Oops, that's a bad G. I don't like that G. Let's fix that G. Ooh, much better G. Yeah. Now, probably should have started with this, but oh well. Such is life. There are three things that you are going to need to recognize to make sure that you are in an infinite sum. Okay? The first thing is you're going to have a list of numbers. And if you see these three dots at the end, with no term after that, that is an infinite sum. Because that's saying that that pattern goes on forever. The second thing to recognize is you will see the word infinite or, oops, I don't have enough room to write there. Or the word infinity, or goes on forever, okay? You'll see that in the directions to the problem. Okay? If this pattern continues, there's another way of saying it. If this pattern continues, goes on forever, if this pattern continues to infinity, if it says this is an infinite sum, that's another way to recognize that you're dealing with an infinite sum. And the last way is in sigma notation, you're going to have a variable on the bottom, and this number up here, your ending number, if that is the infinite symbol, or the symbol for infinity, then you're dealing with an infinite sum. Okay? So let's put these to work. Because these problems don't take very long to do, because there's very limited calculations to do. Okay? So, First off, do I have an infinite sum? Yay or nay? Why, Jacob?
There's
Infinity's up top, right? Yep. Okay. Infinity's up in our ending spot. So this is an infinite sum. First thing I have to find is what, Bailey?
R.
The R value. Do you know what the R value is in this one? It is not 1. It is not 3.
1/4.
It is 1/4 because that's the term that has the exponent attached to it. Okay? So my R value here is 1/4. Okay? What is my first term? 3. Agree? Plug 1 into my function. 1 minus 1 is 0. 1/4 to the 0 power is 1. Times 3 is 3. We got that. Okay? So my sum then, it's an infinite sum. I have an R value. I forgot to ask, is our R value less than 1? Between 1 and -1? Yeah. Okay. Okay. So we're good there. So the sum then is equal to my first term, 3, divided by 1 minus 1/4. Should be blue. Probably don't even need a calculator for this. 1 minus 1/4. 3/4. Think back to 4th grade. How do I divide fractions? Flip the second one and multiply. So this is 3 times 4/3. Really, it's 3/1, right? Divided by, or times 4/3. 3/1 times 4/3. What do we got? 4. So the sum of this infinite geometric series is 4. Okay. Questions? Good? Find me the sum of this series. Infinite geometric series. Yes or no? Why, Robbie?
Because of the infinity symbol.
Because the infinity symbol up top. Love it. Okay? R value of this infinite geometric series. -1/2. Is that acceptable? That falls in my -1 to +1 range. Yes? Okay, love it. First term. One. Okay, put 1 into my function. 1 minus 1 is 0. What -1/2 to the 0 power is 1 times 1 is 1. Sum is going to be -1/2 down there and +1 up there. 1 minus -1/2. 1 minus -1/2. So it's really 1 plus 1/2, right? 1 plus 1/2 is what? 1.5 or 3/2. Okay. Flip. The sum here is 2/3. Logically, does that make sense? Because my first term is 1, but my sum is less than my first term. Does that make sense? My first term is 1.
What are you picking at?
First term is 1. Sum is less than 1. Does that make sense? Why does it make sense?
Because the rate is negative.
Because so every other term is going to be negative. And when I add a negative, I got to subtract. So that's basically saying that if you take out that first term, the sum of the remaining terms is going to be negative. Yep. Makes sense. Okay? Try this one. Find me the sum, and then obviously on these it will say if it exists, because sometimes they might not exist. Infinite geometric sum. Yes or no? Is it an infinite sum or is it a finite sum? Okay. Why? Because of the dot, dot, dot. So it tells me it's going on forever. So it's an infinite sum. R value.
1.5.
Okay, so my R value is 3/2 or 1.5. Is that in my range? No. So does this sum exist? No. And so I have to write no sum exists or sum does not exist. One of those two. I can't write 0 because my sum could add up to be 0. Okay? Just know that. Okay? Okay? So it's either no sum exists or sum does not exist. One of those two. Okay? Homework for this evening. I honestly think that in the, what we got, 7 minutes left in class, you can finish it. So, just so you know.